Hello, and welcome to today's talk, how to get started with image datasets. My name is Tobias Englert, and I will go with you for the next 15 minutes through a small example from a not working dataset that results in a horrible network to a working network, and show you how you can improve if you're stuck when training objection detection network, how you can improve that. So in this session, we'll start with a dataset that is typical for a novice that has no clue about how to start with training detection networks, and then improve on them, and hopefully end with a stable detection network. So let's get started. The object of today's lesson is a snowperson or a tray of snowperson. As you can see, paper tray containing 5 of different or 3 different snowpersons, where they accidentally, of course, contain a highly good chocolate or a very good chocolate. So if this doesn't work out, at least one of us will enjoy the discontinuation of that product later. So we start with the experience in 4 slides. This is a typical data set that you can see when persons start to work with AI. The variance is usually somehow in illumination, maybe a little bit in position, but usually not great. And they create a lot of these images, put it in a dataset, and then annotate them, of course, annotate them good sometimes, and put them in the dataset. Then they train this, and a typical graph could look like this. As you can see, it's not bad, but it's also not perfect. But you would say, okay, I didn't put much effort into my dataset, so this looks quite good. We have loss that continually decreases. We have an MIP, a mean average precision, that is somewhat decent. And obviously, our average intersection over union is also okay-ish. So let's continue. When we first check that, then, as you can see, the lines that are solid, that is the annotation, and then the lines that are like a little bit that are not continuous are the annotation of the network. As you can see, it hits a little bit. So for the first try, probably okay-ish again. And now when you start to then use that network in the real world, into a, let's say, environment where you test bench your network, then probably you get very soon the first oops moment. So the question is, how do we get from this to a network where it happens and works like we actually expected? The first step is usually define very accurately what to detect. In this case, if we look at our object again, you have to define, okay, what do I actually want to detect? Do I want to detect them only in the tray or also outside the tray? Mostly, if you want to detect something, you also want to not only detect it, but work with it maybe, or detect it in situations and with different settings where the object is not in the perfect state. So do you also want to detect it when it's damaged? And if we think about all this stuff a little bit closely, then if our imaginary goal here would be a quality inspection for the snowpersons, where we have to ensure that a snowperson is present, and that in case it's not present in this state or in some way in a condition that is not perfect, do we still detect it? So for the first, let's first check that, how it currently works with our flawed network, and see how this looks like in the real world. So we'll switch over. As you can see, I now opened the Lighthouse. I've loaded my first network, and as you can see, this is now live. I've put the different objects here, and as you can see, this works horrible. It detects one snowperson, but it doesn't detect the rest. And so obviously this didn't work out as we expected. So how can we go from there to a working network? The first thing is, so if we want to detect it for our quality inspection, these are the probable variants that we might encounter. It could be in the tray, could be not in the tray, could be running around in the server room. No, probably, but would be funny. No. So it could be damaged, could be, let's say, show its true face. It could be halfway eaten and not even decent. Or it could be an imposter, completely different snow person we don't expect. So if we have this variance and we expect the network to behave correctly in this, we should probably check it, which we right now did, so it doesn't work, and also then try to improve what the network learns by showing it the right examples. So the real sample size here is 3 trays with different order of the object. And so if we just put the perfect images in there, it probably doesn't learn enough to get it, even if we have a perfect annotation detail. So we need to step it up. And let's analyze the current image data set. So all these factors that we discussed, like just using the perfect images, that adds up. As you can see, there was 0 variance in the scene. I used also, to confuse it a little bit more, a different lens and a different image sensor when I took the image. I violated the aspect ratio by choosing images between 16:10 and 4:3. I also used, there was daylight during my capture that influenced the results, and the artificial illumination then was later used, but only for testing. So that are all factors that add up, that they're adding up. So if just one of this might happen, or 2 of them, well, it's probably not that big of a deal, except the 0 variance in the scene, of course. But if everything comes together, as you have seen, that quite adds up to a network that will not work as you expect, or a data set that will result in trainings that are not really useful. So step 3 is to augment the data set. And for that, I created a data set, a base data set, where you have about approximately 40 images, just of the initial novice data set. I split it about 20 images into an add-on that I then will remove for the purpose of this training. So I don't have too much of the images that just don't show variance, to not give them too high a weight in the data set. I show some of them, but I remove part of them. And then I add additional I call them add-ons, where a few images of a specific theme are shown, and with a very high variance then, to ensure that from each image the network can learn as much as possible. And then I add them up and create a new training. And in this case, I created about 6 add-ons, and together with the base data sets, then use that for training a new network. Some of the main features: dissimilar backgrounds, new positions and orientations, similar but different objects in the scene, and of course some artificial created images to round it up. And for this purpose of this training, I created a base data set which contains the variance we talked about. And for the first training, I used this data set. But I also put another data set to it, which I called an add-on, but with no real changes. So this was the first training, and this didn't work. So, okay. And now, so it learns to actually detect the snow persons regardless of its surrounding. I added another data set, and as you can see now, the snow person is no longer in the tray, but with completely different backgrounds. Third, we added different positionings and inside and outside the box. Again, completely random, but this time artificially. Here we started to add the snow persons in different environments and in different states of, let's say, damage. More of that same, but this time only chocolate. So depending where the damage happens, at least the network knows there should be probably chocolate below, and if it sees that, that's not in the perfect state where you want to sell it. And these are now examples where different backgrounds add also similar objects, just to confuse it a little bit. And when we use the new data set, so you can see now, I augmented it with different sets. Now we have quite a few more images, but each of the image sets now has a very specific purpose of training it. So remove the first add-on, add all the other add-ons, and then I retrained it, and let's see how that worked out. So we're switching back to the cockpit, and we load the new network I trained. And suddenly, as you can see now, this looks quite different. So now we have a stable network that detects it inside the tray, outside the tray, and it detects it depending on how the damage is still. So, yeah. Then, so. As you can see, augmentation of your datasets and creating a high variance datasets really helps to improve the detection results. So in case of having the same experience that we had at the start of the session, I highly recommend to go to steps 1 to 3. First, analyze your situation, what you actually want to do, analyze your current dataset, and then when you know what you want to do and what you have, start augmenting. And by doing that, you surely will see greater success in training detection networks.